folders, and they saw. I think I saw a poster in the Talk Partners section where they've got some of these displayed with the most fantastic comments. The children love looking at these over time. Now, this brings us to ability grouping, and just because it's one of those things that baffles me and lots of other people, that there is so much research to show that ability grouping is wrong, detrimental to children's learning, and yet people continue to do it. So here are 2 pages of some of the evidence. So John Hattie's visible learning effect size of 0.12. Those of you not familiar with his 15-year research project that's absolutely influenced, it's become the Bible of educational research, where he synthesized all the key studies in the world. And he was able to attribute an effect size to all the elements of school life and learning. And anything that comes above 0.4 is important that we take notice of. Anything below 0.4, and the lower it gets, that shows the effect size that has very little impact, and we need to be reconsidering it. So it had an impact of 0.12, one of the lowest things there is. So the Southern Trust report, the evidence is robust, has accumulated over at least 30 years. If schools adopt mixed ability, they're more likely to use inclusive teaching strategies and to promote higher aspirations. The PISA studies, the same thing. The studies have repeatedly found the more schools group by ability, the lower the pupil performance overall. It flies in the face of what, as a layperson, you might think would be the obvious thing to do. Put children of similar achievement level together and they'll learn better. Because you feel a certain way about the grouping and labelling, and there's actually evidence of, especially in secondary schools, of children being put in the wrong group because it's based on certain attributes they've got that are to do with other things, if you like, their handwriting or they write or whatever, and not necessarily their mathematical understanding. So greater use should be made of peer co-learning, since these approaches can enhance the learning of all pupils. Now, it's mathematics that has all the issues around it. That's where people get the most worried, and that's where we've done the most experimentation. And what's come out of that is a sort of philosophy that all children need to be exposed to the same basic key mechanical algorithms, the procedures that we all need to have. We all need to be able to know how to do the 4 rules by the time we leave school. We need to know how to do some basic procedures. And what has happened in the past is differentiation has meant that some children by year 6 are still making arrays because we don't think they're ready yet for long multiplication by the column method because they don't know their tables. So we're taking a basic philosophy that every child should have access to these, and we must support their access to it by giving them the things they don't have that are restricting their access to it. So those children who don't know their tables, you give them the tables so they can access the mechanism. And the differentiation happens at the point at which they are offered a challenge, a differentiated challenge, and they choose the one that's best for them at the stage of understanding that they're at. And people have experimented with mild, spicy, hot challenges, and then that's led to also saying, well, no, I don't want them to think, oh, I'm a hot learner or I'm a mild learner. It's almost like a new kind of stereotyping, even though they're sitting separately. And that's sort of been developed into the challenges having equal status: amazing challenge, incredible challenge, fantastic challenge, but the level of difficulty changes every day. So they never know which one is the lowest one or whatever. But the whole point is children being ipsative learners and thinking, which one's just right for where I am, because I've got to be competing against myself. I like not being in the group, because when you're in a lower group, you think you're not clever enough. In groups, you can't learn anything new because you sit with the people that know as much as you know. The blind leading the blind. I could say a lot more about this, but we have to move on. So the other thing that people have looked at is really good questions, especially at starts of lessons. And we've managed to gather together over the years, now 2 slides full of these fantastic question templates. Some of them are much more popular than others. This morning, people have been talking about the statement, the odd one out's used a lot, true or false, as a way of children having fantastic discussion and revealing their understanding. So, for instance, here's a good example of what went wrong, and especially saving pieces of old or making up mistakes. You can imagine if there were lessons on grammar or whatever, showing children things that have gone wrong and asking them with their learning partners to discuss what do you think's gone wrong here. So while I've been talking, you've been having a look at this. This is an example of the multiplication grid. I've maybe got year 5 children. We introduced the multiplication grid at the beginning of the week. I want to see whether they really get it. So talk to the person next to you about what you think's gone wrong with this child's learning. What have they done wrong in this example? Talk to the person next to you.
Oh yeah, they have the other 6 of them.
There's drinks there if you like them.
So, what's interesting about this, it's fascinating to listen to the discussions children will have looking at what's gone wrong. What I did, and what most people do, is go straight to the calculations there. It's the first thing you look at, the 20 times 6, oh yeah, they got that right, 6 times, oh yeah, I got that right, it's 26 times, And then, of course, you go to do exactly what we tell children they should do, but we are not very good at following our own advice, which is you read the question first. And this person, instead of having 7 lots of 26, has had 6 lots of 27, which of course gives a completely different answer. So it's that fantastic discussion from analysing some of these, just remind you of those wonderful question templates that reveals so much. And again, the importance of not over-planning lessons so that you can chuck them out of the window and think, this is what I've discovered. They haven't actually understood anything about this from yesterday, or they already know, so I don't need to carry on with this, and so on. These are some lovely examples of the statement. Can you see how much will be revealed by the second one? You're beginning your lessons on 2D shapes, and by listening to the children talking about whether these shapes are the same or not, they will have to start using properties vocabulary, and you will see how much they understand from that. I love this one. Because of the ambiguity, fantastic discussion. The more ambiguous these are, the more you will get out of it. So you tell them one is true, 2 are false. And in science, a really good way of getting them to discuss is to take something that would be rather abstract, like what do you think evaporation is, children? And you'll only get certain children really being able to talk about that, but to put it into a real life context. So where does the water go after it rains? Now every child will have an opinion, as you can see. It turns into little pieces and soaks into the ground, said Harry. Ryan says, I agree, it turns into little pieces, but they don't soak into the ground, they go into the air. And so on. So, of course, there could be an activity that starts the lesson, a 5-minute activity like having magnets and pieces of metal and seeing what you can discover, and I can learn as much from that as the question. Now that takes us on to learning objectives and success criteria, and the key thing about learning objectives is that it's absolutely essential. It's the absolute foundation of any learner's job, is to know what on earth they're learning, why they're learning it, what's the point of it. And in the old days, when I started teaching many years ago, that wasn't the norm at all. People planned activities and children were searching for meaning the whole time and continually asking what it was they were being asked to do because they didn't know what you were actually really looking for. The learning objective, of course, underpins everything now. And I think we're very well, versed in the fact that they need to be decontextualized and so on. And learning objectives break down into success criteria. It's actually only skills that are useful to be broken down into success criteria. Knowledge simply breaks down into bits of knowledge. So success criteria are simply a breakdown of the skill, of the learning objective. What does it mean to write a newspaper report? What do you have to include? And the whole world of success criteria splits into 2 basic groups. It splits into those success criteria, or those learning objectives rather, that are closed, that have yes or no kind of answers to them. You can do it or you can't do it. So if you think of a lot of mathematical procedures, if you think of a lot of secretarial skills, you know, grammar, punctuation and so on, those things have rules. And therefore the success criteria are remember to success criteria. You have to remember to include these things, otherwise something will go wrong. You can't choose out of that list, you have to use them all. If you want to write a letter, you have to have these features. If you want to, you know, and so on. Now those are the closed learning objectives that have the compulsory elements in the success criteria and the remember to kind of idea. And they don't really have an element of what does a good one look like, other than what does a correct one look like. But there is no real continuum of quality. You know, once you've got capital letters and full stops in the right place, then you've got it right. You can't say, well, here's one that's even better, even better, even better, that's got full stops and capital letters right. It is right or wrong. Now, on the other hand, you have learning objectives, which are what I would call open learning objectives, for which the success criteria are a menu of tools rather than rules. Tools that you can use, but you don't have to use them all. They will help you. So, for instance, most writing, you know, the opening to a scary story. Here are some possibilities. We can look at 3 fantastic openings to scary stories, and we can talk about the features that we see here, and that's how you get the children to co-construct them. We make a list of all the features, and we would choose which of those to use. But clearly, we would not say you must use all these or it will be wrong. Now, those learning objectives that have these tools, choice, you choose from success criteria, they all need an analysis of what makes a good one, or WAGGLE as it's become known now across the country. The others don't, but they do, because the only way you can get quality is not by the inclusion of the success criteria, but by seeing several examples of excellence. So you might say, well, I've used all the elements of this this particular, you know, this success criteria for characterization that we brainstormed, but I don't know whether I've written a good piece of writing or not. And that comes from seeing excellence and analysing it and saying what makes that characterization so much better than that one. What's actually going on there? And I got some years ago from my Hertfordshire learning team the very first example of nursery success criteria. Look at those. The foundation of success criteria is just simply asking the children, what are the rules we should have for when we're doing this? And in this teacher's nursery, she has posters all around the room for beginning reading, beginning writing, going to the toilet, sharing, and using the role play areas. At this moment, there appear to be 4 different types of math success criteria, but this could change at any minute. I mean, it keeps evolving and developing all the time. There are those kinds of, let's see to have the examples there. There are the compulsory steps. You know, you have to do these things in this order to do this particular algorithm. There are the choice of methods kinds of success criteria, where we're doing adding 2-digit numbers. You can choose any method you like, including your own method, and then the success criteria become the choose from. Then you've got application problem solving, word sums if you like, ideas, where the success criteria would be problem solving strategies, like remember to make an estimate first, underline the keywords, choose your resources, and finally, every time we do maths, and that would be a poster in the classroom. Excuse me, I feel my throat going.